All right, in the interest of time, what I'd like to have everyone do is try the checking in part so that we can debug any problems that are with that. So stop doing what you're doing right now, go to the point where it says checking in the project. You can answer these questions later, but I want to make sure that you do the checking in thing. So first off, and I've checked that with all of you, when you, that in the CS185C directory, that it was important that you have inside there it must have a .git and then of course the workspace next to it. And if you don't see the .git, then that means that it wouldn't be under version control. But if you see the .git, and I think I saw it in everyone except your group back there, then that's fine. That means that this directory is in fact versioned. Then you have the workspace, and of course in there now you're going to have lab 01, and then inside here. And now I realize that the very first time it's not really going to be working for the scribes, and I'll come to that a little bit later. But everyone who's a driver will see this thing and will be able to push their stuff. But before pushing it, make sure that you make a file called .gitignore, like it says here in step 5. Make sure that the name gitignore is spelled just so. It should have a period in the front, but it shouldn't have a period in the back. That's the end of the sentence. So, and finally, you should have 10 characters, the period in the front, and 9 letters. And inside there, paste in these lines here, and at that point you'll be ready to start committing. And so the instructions are a little bit further down where it tells you to run git add. That'll add in the stuff that you've done today. Git commit. That'll make it committed into your local repository. And then git push, and that makes it end up on the server where I can then retrieve it. So everyone who's a driver should go and start doing those steps now. When you're a scribe, you should instead do the following. Inside the directory that you checked out, the CS185C, you locate that directory wherever you have it, hopefully in your home directory. Inside that directory, manually make a workspace directory, manually make a lab 01 directory, and inside there, put in your report.txt. If you like, you can put the .gitignore, but as described, you don't have to do it right now. And when you have this manually created directory structure, then you can also do the add and push as it's described there. And that way I get the report. Next time around, when you flip, then you will have to make sure that you tell Eclipse to make a workspace inside this directory, and then the driver and the scribe will be in sync.
So before I had the workspace directory, I tried to make the CS1 workspace. How about it get why would you want to do that? I have one space and then above that is
Yeah, I'm a little concerned about what program are you using to handle it? But it's not what's over. That's like Word. That's how we have to use the text editor. Inside Ubuntu it's called LeapPad. But really, you're a programmer, right? There's email. There's another email. Oh, you're using Ubuntu?
Yeah.
Oh, I know nothing about Ubuntu.
G.
What do we put a report inside a folder?
The reason that, I didn't tell you to install commands. I didn't give you the detailed VM. Okay, so, yeah, the G editor will work.
Maybe the notepad on the workspace. But it's not. Okay, yeah, that's actually a relation to So Scribes commit done with Lab 1 as well?
What's that? Yes.
To the report?
Yes, that's the report. Do it in that way.
I know that it's in that folder, right?
The file is when it becomes in the terminal?
Yeah.
Yeah.
I'll go show you. You have to see in your CS.
What is that? Oh, there we go.
Yes.
Yeah, there was no, no. It's in Linux, VM, transfer block. Yeah, that's what you guys
Because this is just trying to do all this file. Yeah, okay.
All right, so I hope that you're able to check these things in. So again, here are the commands that you need. The git add does adds the files that you've just done. Git status will show you what the listing is. In the interest of time, just make sure that what's in there is nothing that obviously should not be checked in. Like there's 1,000 metadata files, none of which we want. We don't want the class files and so on. Then here the commit you can put in done with lab 1 or not quite done with lab 1, whatever, and then do push. And at this point, it should work. And the way you can verify that it worked is you can go into your temporary directory and clone the repo again, and later you can throw away the clone. But then when you look inside it and you see all your files, then you know that it worked. And then it's a super good habit to have the first couple of times that you establish a new repo. Or like after an exam, if you want to make sure that all your files made it there in one piece and you didn't forget to add one, just clone it into temp and then later throw temp away. And so, of course, you're not going to remember the command to clone it, but it is in one of the slides and you just want to copy and paste it. What I actually do with any of these technologies that I use on an occasional basis, such as Git, and I can highly recommend that strategy, is I make myself a little file, as a little cheat sheet. So I'll show you my Git cheat sheet. I hope I didn't put any private passwords in there. So I made a file called git.txt. In the directory I put all my little cheat sheets, and I simply pasted in the various commands that I might need. So here's like the git clone from this Zoidberg thing, so that I don't have to remember this, and then I can just copy and paste it when I do need it. I would suggest that. Over here you see just a few random things that are copy and pasted here, because I can't remember anything at my old age. So you'll see some notes here. So do the same thing. Over here I had some locale issues and I copied that. So strongly recommend the strategy. Anyway, so let's hope that works out. We'll have to debug any problems that arise in there as we go by. And what I want to do in the, and any question right now that I need to deal with? So what I want to do for the remaining 15 minutes is go over a few of the things that you need to know for the homework, so that we can, that you're prepared for that. Because homework is due before the next lecture. So what we've done today is you've just looked at the very basic application. You've seen how to put some text on a screen. Maybe you've gotten to the part where you've done the image, and you've dragged and dropped that those controls on the on a form, and then the form would be displayed. And of course, in a real application, there are many more gizmos that you want to have on a form or on an activity, as it's called in Android. You want buttons and scroll bars and text and whatever, and you need to arrange them in some way. And then that's called a layout in Android and in Java and a bunch of different systems. And there are, in principle, 3 different ways on how you can achieve a layout. If you've ever done any Java Swing programming, you would have seen that layouts are achieved programmatically. You attach a layout manager to the form, and then you add components to the form, and then the layout manager that you have chosen will do the arrangement. You might have to give the layout manager some information. So if you use like a grid bag layout, for example, you have to tell it which of the components should grow or shrink or be attached to what, and so on. So you would do it by writing this Java code. In HTML, on the other hand, when you do layout, just imagine that you do layouts by, say, using tables or by using CSS. It's declarative. You say, without code, you say, just with a declarative syntax, what it is that you want to achieve, and then it's up to the browser to do the layout in the way that you've prescribed. And finally, in Visual Basic or similar systems, it's drag and drop. The programmer is not expected to either be able to code or to do declarative syntax, but they simply take the mouse and they drag and drop the components where they should be. So in Android, it's a bit of all of the above, but what we're going to be doing at first is we're going to generally start with a drag and drop interface, and it makes this XML file that you've seen, and then it turns out that the XML file is usually pretty good for simple layouts. So it uses by default this thing called a relative layout, and when you look inside the XML, you're going to be seeing, particularly once you have a few components, you'll see that in the homework, you'll see these attributes. The Android colon is just a namespace. You'll see like layout below, layout to right of, and some other attributes. And what I found when I do this with anything that requires more than a couple of buttons and text areas, that I don't really know how to use this visual tool myself, so I drag and drop them the way that they kind of seem to look right, and it tries to guess your intentions. It tries to figure out what it is that you want to be next to, and it gets most of them right and a few of them wrong. So when I did the homework, I found out that it actually made all the text fields, even though I thought I patiently dragged them right next to the buttons, it made them align with the left, and so the text fields and the buttons were superimposed, which had an interesting look but not a very useful one. And so then I had to go into the XML and manually fix up the XML. So that's typically the process that you go through, that you do some drag and drop to get a basic alignment, that you don't have to look up all of the fuzzy syntax for this thing, and then you clean up any minor syntax error, not syntax errors, semantics in that the tool didn't manage to guess for you. And so the relative layout is actually pretty darn good. It lets you specify that a component should be next to that, on top of this, that the baselines of two things should be aligned. So that's useful when you have a button that has a bunch of stuff to the top and bottom, and then you have text next to it. You want the two texts to be aligned on the baseline of the text. You don't want the text to be aligned with the top of the button or some such thing. So it's really quite good. For more sophisticated layouts, you can nest things, and any Java programmer will have experience with that, where you put a panel inside another panel to achieve layout. You can do the exact same thing inside the Android layouts. And at some point, we may get more into exactly what you can do. For right now, relative layout is your friend, just the basic default layout. And so do that in the homework to get your buttons aligned. If you run into some issue, put your layout file, the XML file, onto Piazza and a screenshot of what it looks like when it failed, and we'll be glad to help. And so that actually is a great advantage of having this XML format. It's a textual format. It's easy to exchange. It's easy to look at and critique. The next thing is with specifying text strings. If you've gotten to the point in the lab where you changed the message from hello world to hello Fred, then you've seen that you can do that declaratively. There's two ways you can do it. You can actually put an Android text and then put a literal string in there. But that wasn't how they did it with hello world. They instead indirected that through the string table. So they said the text is, this means look it up in the string table, and then in the string table it was given a name. Why did they do it that way? Why do they not make you put in literal text into the form? Exactly, localization, right? So any problem in computer science can be solved by an additional level of indirection, and so that's what they do here. This way you can localize your string table, and you don't have to muck with the layouts. So in fact, when you don't do that, you'll get a little warning triangle. For the homework, that's okay. You'll get the triangle, but don't worry about it. So what if you want to update the text dynamically? Then, of course, you can't easily do that. Instead, you want to run some Java code, and I'm giving you the Java code down here. You have to get your text view component. It's a Java class, and then you call the set text method on it, and then you can set the text to anything that you want. But that leaves the question, how do you look it up? And the lookup is a little hokey. What you have to do is you have to give the form an ID. And the easiest way of giving an ID is you right-click on the field and assign an ID. And the ID has a numerical value and a textual value. And you could, if you wanted, you could actually choose the numbers yourself, but generally people don't do that. Generally you want the system to number them through, and that's where the plus comes in. The plus here says, just make a new ID for me. And so this way a new ID is created for you, and then it's attached to the symbol here, and then we can later look it up. The R class, that's this class that mystically gets all of the stuff that you might need to look up, such as the various layouts and so on, the IDs, the strings. They get put into this R class, and then you do r.id.question text. The rationale for using the R class is that way you can use auto-completion in the IDE. That's the only reason that they put it in a class. So that way when you type r.id.q, then you hit Control space, and it gets auto-completed, and that way you can't make typos. Because it's a common thing, of course, with any of these systems that rely on ID strings, that you accidentally type in the wrong string and then you get an error at runtime. So this way it gets checked at compile time that you don't have silly errors. That's kind of a nice feature. So it's a trick, right? They synthesize this class for you, and one doesn't usually look into it. The only reason that is auto-completion. All right, so when you do that, then you can set the text, and that's something you're going to have to do in the homework, where you have to set the text of a thing on the top and a few strings to the right of the buttons. Next, what you're going to have to do in the homework is it asks you to put in like a quiz question on the phone screen, just like the kind of questions that we have at the beginning of every lecture. So there's a question, there's 4 options, and each of them has a description. And of course, when it's an application, you can't hardwire the quiz questions into the app. That wouldn't be a very uninteresting application, right? They'd have to download a new app for every question. That'd be silly. You want to be able to read them from somewhere. So where do we read them from? Well, obviously from some website. So I've provided a text file, just one line per information item that that your application needs to read. So the application needs to go to the internet, read this one file, just like what you did in the prerequisite quiz, and make an URL connection and grab the data. But when I tried this, I just pasted in the code, and I thought it's a bad thing to do. You're not supposed to make an internet connection right in a UI callback, because what happens if for whatever reason your phone happens to not be connected on the internet, which happens on a regular basis if you use T-Mobile, not wanting to name any names here, then your application would just hang and wait, and the user would just not see anything, right? The user would load your application, it wants to find the quiz questions, and it would just do absolutely nothing, and it would be very disconcerting for the user. And depending on exactly how the phone works internally, particularly with older phone OSs, it could actually get the entire phone UI waiting, and so nothing would work until your thing came back. So that would be very, very bad. So what the Android people did about that is they actually rigged all of the internal functions that do time-consuming things, like reading data over the internet, to double-check whether they run in the UI thread. And if they do, then it'll throw an exception and will not even allow that application to complete. And so that's what you're going to be seeing in the homework. And the way to deal with that is to use async tasks. That's a convenience class that was provided. And it's if you've done a similar thing in Swing, Swing has a Swing worker that works the same way. But if you haven't, it's easy enough to use. What you have to do is you have to make your own class that extends async task. It has 3 type parameters that I'll discuss in a minute. And you need to provide 2 methods. There's a couple more methods that you can provide, but you must provide these 2. The first one is the task that you want to have done in the background. And you simply put in here what happens. Oops, this is not a bit method, it's a typo. It returns a string. So you put in the task here, and I made a minor mistake. I didn't put in the exception handling here. You'll see that in the homework, how to do that though. So this task, it goes out and gets strings from a URL. And eventually this task will return. And the framework will capture that return, and when that return is finally become available, then it'll make a callback on the UI thread on this method here with whatever the result was. And so in here, then I finally do the set text thing. It turns out it's important that you do that on the UI thread because the components are not thread safe, and everything on the UI thread is serialized, so we don't have to worry about that. If you simply follow this recipe where you say, here's the stuff that's time consuming, here's the stuff that needs to be done after the time consuming thing has finished, then it's very simple. Then you make yourself an object of the class that you just wrote, and you call the execute method on it. In the execute method, you feed it whatever it is that you want to have provided here. It gives you the opportunity of giving more than one item. That's the 3 dots here. In this case, yeah, we don't take advantage of that, so that's why I'm just getting the bracket 0 item here. And the type parameters, this one here is the type of whatever it is that I want to feed in here. Oops, I made a mistake again. I should have put new URL in here because it takes a URL and not a string. This thing here has something to do with progress reporting, which we're not doing in this example. And this thing here is the type of the result. In the homework, the type of the result is likely going to be something different, and you'll have to adjust for that. So that's async task. Next, it's convenient to do some simple logging for debugging purposes, and the homework makes you do that. Now remember, your phone doesn't have system.out, so any logging has to go through the log manager. And the log manager is active. You'll see it actually in the IDE. You'll see a million log messages passing through. It's called logcat, and you can see the output in Eclipse. And you can. Oh, by the way, when you use it, you will find that that's a window that you want to detach because it's tiny. Do I have it detached somewhere? Okay, I'm not finding it right now. So that's just as a tip to detach that. And you can also actually attach, if you have a phone, you can see the log output out of that. And believe me, you will be doing that when project time comes along, because oftentimes that's the only way of getting any decent debugging information. There's also lots of apps that you can install on your phone. The one that I use is called Catlog. I'm not sure it's the best, but I can remember its name. And the logging API is purposely made super simple so that everyone does it. Lots of times people in Java programming don't like to use logging because to set up the logging properties is such a hassle. But so they made it as simple as they could possibly do it. Log.e logs an error message. Log.d logs a debug message. Log.w logs a warning message. So they don't even want you to hit control space. They just want you to get going and do as many logging messages as you can. You put some kind of a tag string here, and as a rule of thumb, it's a good idea to just use the class name. You can filter on those tags, and that way you can distinguish your logging message from the multitude of, there's millions of other logging messages that get generated. And then you put whatever message in here. Like for an exception, you might just want to log the exception message. And so it's the simplest thing in the world, log.d, and you go on to make your log message. Finally, permissions. Any app can paint a picture on the screen, put in buttons and so on, but everything else that costs the user money, depending on the data plan, and the phone doesn't know what your data plan is, or that might compromise privacy, such as using the camera, requires permission, right? You wouldn't want to install a random app that can take a camera of you and whatever it is that you might be doing. So those permissions are displayed to the user at install time, and as we all know, every user out there carefully scrutinizes the list of all permissions before they click on OK. But in theory, they could. To read data from the internet, you need a specific permission. That's the internet permission. And so the easiest, and you need that in your homework, the easiest way to do that is to do it in Eclipse. There's a permission button. If you can't figure out how to do it, just put a question out on Piazza. So I'm putting in these things here in record time because you need those to be successful in the homework. Every one of them is pretty trivial, but I wouldn't want you to struggle with those things and have to Google for them. So in general, what I'll be doing in the next few weeks, so to get us up to speed, is I'll work through some examples, and I'll give you bits and pieces of what you need to do in the Android ecosystem to get those examples going. Because when you do it like the book does it, you'll see it's pretty boring when they tell you the whole story, one aspect at a time. So I hope that you'll find it more engaging by getting your hands dirty and then just discovering these things as we go along. We'll do more of a formal summary after we have a bit of experience in our belt. All right, that's what I have for today.